Okay, in this section, this is going to be 6.1 notes, and we are going to be looking at exponent rules. This video is just going to give you a really brief introduction to exponent rules. So let's remind ourselves what exponents are. If I have something like 2 to the 4th power, that is repeated multiplication. So that means 2 times 2 times 2 times 2. And of course, 2 times 2 is 4. This set of 2 times 2 would be 4, and I would get 16 as my answer for 2 to the 4th power. Now what we'll be doing in this section is we'll be working with exponents with numbers, but also with variables in this case. So let's begin by doing an example that looks like this. So let's say that we have 2x to the 3rd power times 3x squared. Now, right now we are going to just do these problems by thinking about what this means here. So I've got 2 with 3 x's times 3 with 2 x's. Well, if I want to reorder this, I could. So that'd be 2 times 3. And I could put all 5 of the x's together here. 2 times 3 is 6. And then I would have x to the 5th power. So to simplify, 2x to the 3rd power times 3x squared, I would get 6x to the 5th power. To do another example that would be similar there, I could have something like x squared y times x to the 3rd y to the 4th. If I have this, what this means is I've got x times y times 3 x's and 4 y's. So if I think of those together, I've got 1, 2, 3, 4, 5 x's, and I've got 1, 2, 3, 4, 5 y's. So I could write this as x to the 5th times y to the 5th here. So whenever we're multiplying there with our exponents, this is what we'll do. Next, we've got the possibility that rather than having two things multiplied together, we may have something raised to a power. So it may look like this. X to the 3rd to the 2nd power. So if we have something like this, let's think of what this tells us. This square right here, the 2nd power, tells us that we have x to the 3rd times x to the 3rd. And of course that x to the 3rd means that we've got 1, 2, 3 x's times 1, 2, 3 x's. And that is going to give me x to the 6th power there. So x to the 3rd to the 2nd power would be x to the 6th power. Let's do another example that involves taking something raised to a power and raising it to another power. So let's try this. 3xy squared to the 3rd power. So what this means is I'm going to have 3xy squared times 3xy squared times 3xy squared. Now whenever I write that out even longer, that's 3x times y times y times 3x times y times y times 3x times y times y. So in this case, I've got 3 times 3 times 3. That's going to give me 27. I can put those together. I've got 3 x's. I can put those together. So that would be x to the 3rd. And I've got 6 y's. So I can put those together. And I'll get y to the 6th. So 3xy squared to the 3rd power is going to be 27x to the 3rd y to the 6th whenever we simplify. Okay? So far we have looked at multiplying two things that had exponents. We've looked at raising something that has an exponent to another exponent. The other thing that I want us to look at is division. So let's look at a couple problems with division. So let's say that I have x to the 4th power over here for my x to the fourth power over x to the second power, let me change that. There we go. This means that I have 1, 2, 3, 4 x's on the top and 1, 2 x's on the bottom. Now, whenever I divide x by x right here, and whenever I divide x by x right here, x divided by x is just 1, so those cancel out. And right here, x divided by x is just 1, so those cancel out as well. So I am left with x squared. It is in the numerator. I could put this over 1 if I want, but whenever we have a 1 in the denominator, it's unnecessary. So I would prefer for you to write the answer as just x squared. Now, let's look at one that's going to be a little bit different. Let's say that we've got x to the fifth power over x to the eighth power. So here, I would have 1, 2, 3, 4, 5 x's on the top, and I would have 1, 2, 3, 4, 5, 6, 7, 8 x's on the bottom. So in this case, I've got 1, 2, 3, 4, 5 sets of x's that are going to divide to be 1, so those cancel out. This leaves me with x to the third in the bottom of the fraction. Now, I must put a 1 in the top of that fraction there, since there's nothing left. Whenever we divide all of these off here, x divided by x, we're getting 1 for all of these, so we can put that 1 right there in the top. You must leave the 1 here. This is not the same as x to the third, so we get 1 over x to the third in this case. Let's look at a couple more that have coefficients with them. Coefficients are the big numbers that come in front of our variables. For example, 2x to the third y to the fourth over 5x squared y to the fifth. So here, 2 and 5 are my coefficients. Those are my big numbers. So what I'll have it here is 2. I'll have 1, 2, 3 x's and 1, 2, 3, 4 y's over 5 times 1, 2 x's and 1, 2, 3, 4, 5 y's. So I've got 2 x's that can cancel. I've got 1, 2, 3, 4 y's that are going to cancel. Notice here 2 and 5 do not reduce, so we're going to just have to leave those alone. So in the numerator, I'm left with 2x. In the denominator, I'm left with 5y. So my answer here is 2x over 5y. Let's do one more of those. Let's say that we have 6x to the third y over, let's do 18x to the third y squared. So whenever we look at this, we've got 6x times x times x times y over 18x times x times x times y times y. Now, in the last problem, 2 and 5 would not reduce, but here 6 and 8 will reduce. So what we want to do is reduce those. Both of them will divide by 6, which will give us 1 here in the numerator. If we divide the bottom by 6, we'll get 3 there in the denominator. And we've got 1, 2, 3 sets of x's that cancel and 1 set of y's that cancel. Notice our x's canceled out completely there, so we're not going to have any x's in our answer. Nothing is left in the top except for this 1 right here. So we're going to have 1 over, and then we will have 3, and then we have a y with that. So 1 over 3y is what this one will reduce to. Okay? You have an assignment that you're going to do for me tonight. Be thinking about how you can come up with some shortcuts to make this a little bit faster as you work on that assignment.